Elizabeth, you said you wanted to be a vet. And I was like, absolutely right. That is my calling. This is what I want to do. And she said, you do realise that you're not particularly keen on outdoor activities, and you actually have expressed almost zero interest in biology. To which I said, well, what's your point? And she just passed over this careers assessment form. And the top job was writer, and the second job was astronomer, and told me to go away and reconsider my life choices. So from there, I went on and specialised in maths and physics, and did indeed drop biology. And then I went and read physics at university. And then in my fourth year, I attended a course on cosmology run by Professor Carlos Frenk at Durham University, and realised that I could combine my love of computer games and spend my life really building universes in my computer. And that would give me a feeling like a minor deity. So possibly this was an even greater calling than putting your hand up inside a cow. And so I went for it from there.
Very good. Elizabeth, tell us about your PhD thesis first, and then your subsequent research and the different organisations and institutions you've been in.
So with the idea that, building universes and feeling like a god was a great career option, I applied for PhD positions in computational astrophysics. And that took me to Oxford to work with Professor Greg Bryan. And our cornerstone of our work there was looking at how the gas in galaxies form stars. And from there, Greg actually moved during my PhD, and he took up a new professorship at Columbia University in New York City. And there was an option there to spend a few months at Swinburne Institute of Technology. So I actually wrote most of my thesis at Swinburne while interacting with the group there. But then from there, I took up postdoctoral positions at the University of Florida and at McMaster University in Canada before accepting a faculty position at the University of Hokkaido in Japan.
Right. Now, I believe you moved to Japan 5 years ago now. So how's that transition going?
So astrophysics, it's such an international field. There's only about 3 men and a dog really working in this area. So in some ways, it doesn't really matter where you're based. Departments operate fairly similarly. But that said, there are certainly some differences with working in Japan. I would say one of the struggles that I continuously have is with names. So for example, in universities I worked in Europe and America and Australia, anyone above a grad student, you just use your first name. So I'd just be Elizabeth.
Yep.
But in Japan, it's pretty common to use the family name, even among fairly close friends. So you have family name plus a suffix that indicates your seniority or sometimes even your gender. So I'm typically Elizabeth-san or Obitaska-san in Japan, which is like Wuztaska.
Yep.
And this largely works, but of course everyone also understands that in Western countries you use the first name. So we end up using a mix in our laboratory where sometimes people call me Taska-san and sometimes people call me Elizabeth-san. And that works fine, except when I'm trying to write an email to another colleague who isn't Japanese. So for example, one of my students goes almost exclusively by his family name. And when I write to one of our colleagues in Australia, do I switch to his first name, even though I've never called him that myself? Or do I keep using his family name, even though that would be a very strange translation to suddenly refer to him as Mr., in an email where I'm referring to myself as Elizabeth and my colleague by their first name? So what tends to happen is we all use a mix, and typically as a result, no one knows which is the first name and which is the family name.
Okay.
Which can lead to some confusion.
I'm sure you'll work it out. The first 5 years are the toughest, they say.
That's what I'm hoping.
Okay, so can you tell us a little bit about where you're currently working? What does your working week look like, Elizabeth?
So at the moment, I'm at Hokkaido University. It's in the city of Sapporo, which is on the northern island of Hokkaido in Japan. During my week, I have a variety of activities. I teach an undergraduate physics course, and my class is very international. I teach in English, so typically my students are from all over the world studying at Hokkaido, with a few brave Japanese students deciding to risk an English physics course.
Yep.
Then I also meet with my graduate students and we discuss their projects. I still find time for my own research. And I also started and have run Hokkaido University blog, where I discussed different research at the university sort of roughly once a month. So that would be a pretty typical week.
Very good. Now, I looked at some of the research papers you've done, and there's a couple of recent ones that you've published on giant molecular clouds. Can you tell us, firstly, what is a giant molecular cloud and why you study it? And then can you tell us about some of the technologies that you use to study things like giant molecular clouds?
Right, so a giant molecular cloud is really like a nursery for stars. So these are clouds of cold gas in the galaxy, and it's where we expect really all the star formation to occur. So if a star is being born, the properties of these clouds, their mass, their size, how the gas is moving inside them, these are going to be what the star first feels. So really, they're going to be governing when and where a star is formed.
Yep.
So understanding how these clouds form and what happens to them during their lifetime, and indeed how long they live, gives us an insight into how stars form in a galaxy like our own Milky Way.
Yep.
So to study this, my work is computational. So I build really a model of the galaxy inside a supercomputer. And I start off with a very simple picture of a galaxy, really just a rotating disk of gas. And I let that gas cool. And as it does, it starts to clump and fragment as gravity pulls on the gas. And it creates these clouds. And I can track them through the simulation and ask, how long are you living? What's happening to you during your lifetime? Are you meeting other clouds? Are you just ticking along quietly? Does the star formation inside you destroy you? That sort of thing. Okay,
so you're building these models, and these are digital models. What language do you use to build that model?
So the code I use is called ENSO. It's one of the major codes used in astrophysics. There's quite a number, but ENSO is mine. Well, ENSO is the one I use. It's certainly not just mine. It's written in actually a mixture of languages, C++ and Fortran.
Wow, Fortran's been around since 1972 at least.
And then to analyse the simulation and sort of pick out these clouds and find out what they're doing, I use an analysis package called YT, which is written in Python.
Yep, very good. Now, the internet lit up like a beacon. It went supernova this week. We had the news that at Proxima b, it was discovered to be Earth-like. It was habitable. There were aliens there. And I saw a piece of writing that you did on it, which brought us back to Earth a little bit, so to speak. And I thought it was so good. That's why we contacted you in the first place. I've made a tiny URL for it. So for our listeners, we'd recommend they go and read this Scientific American blog by Dr. Elizabeth Tasker. It's at tinyurl.com/e-tasker. Centaurus Proxima b. Can you explain exactly what we know about this planet?
Right. So unfortunately, for anyone who is currently packing a suitcase, the only thing we actually know about this planet is we know the minimum mass. So we don't even know its exact mass. We just know the lower estimate for it.
Yep.
And the lower estimate does indeed say it is slightly larger than Earth, about 30% more massive.
Yep.
But that's not enough to start holiday vacation.
Okay.
Because it could be an awful lot larger. It could be so large that it's not even rocky, but is actually more like a version of Neptune. And I don't think any of us really want to spend our summer holidays at Neptune. So we have a minimum mass, and we also know the star it's orbiting, it's Proximia Centauri, and we know how close it is to that star. It's actually extremely close. It's only 5% of the distance the Earth is from the Sun to its star.
Okay.
So a whole year on Proxima Centauri b is over in just over a week, about 11.2 days.
Yep.
So this might instantly rule out really anything interesting, and it doesn't. This discovery is genuinely exciting. The thing about Proximia Centauri is that it's a complete weakling. It's what we call a red dwarf or dwarf star,
yep,
which means it only has about 10% of the Sun's mass. So in fact, the amount of heat and light that this planet receives is about 2/3 of what we get on Earth. But of course, that doesn't really tell you, in fact, it doesn't tell you at all, what the surface conditions of the planet are like.
Right.
If, and this is a huge if the planet was Earth, then it might be warm enough to support liquid water on the surface.
Yep.
But is the planet like Earth? I mean, we only have a minimum mass. We don't know anything about its atmosphere. We don't know whether it's even rocky for sure. So there's a huge amount of assumptions to assume that the conditions on the surface are anywhere close to what's needed to support water. And then we don't even know if water would even be there.
Very good. So we've seen so much hyperbolic reporting, Elizabeth. Can you explain how the terms habitable and habitability are being abused and how there's other indices being used that don't actually impact on any sort of quantitative meaning of habitability?
Yeah, it's a tricky game, and I understand why people are confused. I mean, for a start, let's face it, we all want to find aliens. So
yes.
There's a huge temptation that as soon as we see something where the mass or the radius is about Earth-like, to get very, very excited. And excitement is justifiable. I mean, it's only since 1995 that we've known of any planets, or at least many planets, outside our solar system. So it's okay to be thrilled by this. But we can't say anything yet about habitability. And I think one of the points of the confusion is that scientists often talk about something called the habitable zone.
Yep.
And this is the region around the star where the light and heat coming from the star would allow surface water to exist on a planet that's like the Earth.
Yes.
And by like the Earth, I mean an atmosphere and surface pressure that match our planet. Now, in reality, how likely is that? Well, we just don't know. If the planet is more massive than the Earth, then it might still be rocky, but it might pull down an atmosphere that's much, much thicker, leading to a more Venus-like atmosphere and surface conditions, which most certainly is not supporting liquid water.
Exactly.
So all the habitable zone tells us is it tells us about the location of the planet. It does not tell us anything at all about the planet itself. Indeed, around the habitable zones of stars we know, I believe there are roughly 5 times the number of gas giants like Jupiter than there are planets that we suspect might be rocky.
Okay.
And it doesn't matter where you put Jupiter. Jupiter is never going to be habitable.
Yeah, just like Venus and Mars.
Exactly.
Okay. Now, that reminds me of Carl Sagan. He said that if we make extraordinary claims, we also need extraordinary levels of evidence.
Yes, and the disappointing fact is we just don't have it. What we typically have for a planet is either the radius or the minimum mass. If we're really lucky, and unfortunately at the moment we're not for Proxemia Centauri b, we might have both, and that could give us a bulk density. But there's still not enough to start understanding surface conditions. So until we can start probing the atmosphere of these planets, we can't really say anything about what it's like to stand on the surface. And until we can say that, how can we start talking about life?
Very good. We don't even know if this planet passes in front of it.
No, we don't know yet whether the planet transits. If it did, we could get a radius, and then we could start at least determining if the planet was likely to be rocky. At the moment, it's all guesswork.
Yep. Okay, Elizabeth, we can finish off now with your personal take on astrophysics and science in general.
Right, well, I guess since I'm a female astronomer, it makes a little bit of sense to talk about women in astronomy, which we're still rather underrepresented. When I first took my position at Hokkaido University, it was actually what's called a positive discrimination position.
Yep.
Which means that it was only open to female applicants. And before taking the position, I admit I was pretty sceptical. My concern with positive discrimination is that if people think that senior female scientists have been hired under these specialised schemes, they might think the only reason they got hired was because they were a woman.
Yep.
And that is a dangerous route to go by, because it means people will say, okay, yes, Elizabeth, you're an associate professor, but let's face it, we tilted that playing court in your favour. You wouldn't possibly have been that good or good enough to take the position if you'd had a fair contest with all astrophysicists, men and women.
Yep.
And that would cast into doubt all the science of all female astronomers, which is not helping anyone.
Yep.
So I was sceptical of these schemes, but it turns out that I think rather like relationships, when you meet the one you really want, none of these reservations really matter. So when I was offered the position at Hokkaido University, I was very excited to come to Japan. I really wanted to come here. And so I swept my reservations under the carpet and took the post. And after a year, I realised that my reservations were groundless, partly because it wasn't even that I was doing anything special. I was just being here, doing my job.
Yep.
And at the end of the year, one of my friends, who was a graduate student here, came to me and she said, I'm going on to a postdoc and I never even would have applied if it wasn't for you. And I was actually astonished because at no point had I sat down and said, hey, you must do a postdoc. All I'd done is I'd asked her what her plans were.
Yep.
But what I realised is having someone there and just showing someone like you the next rung up makes you realise that it's possible.
Okay.
And that makes a big difference to how people think about whether they could apply for jobs. And so what I realised is these positive discrimination positions, you put them there in order to get rid of them. Like there's easily enough very strong female candidates that you're not by any way compromising a position by restricting it only to women. You're going to get a candidate that is definitely worthy of the position. And in doing so, the next time you open a faculty position, you're going to get several times the number of possible applicants because people and women and minorities will see that this is a completely valid career path.
Thank you very much for speaking with us, Elizabeth.
No problem at all. Thank you for having me.
That was Dr. Elizabeth Tasker from Hokkaido University in Japan.
Righto, and helps if I increase my mic gain. Okay, that was a podcast recording, episode 10 from astrophys.com. Thanks to Brendan O'Brien for that, and episode 10 of Dr. Elizabeth Tasker talking about habitability claims for Proximia Centauri b. If you think that there was a bit of distortion on that was on the original recording, I'm sorry to say. Couldn't do too much about that. I did try to EQ and change things around, but you can only do so much with if the original recording is not so good. That little bit of reverb in her background in that recording also made it a bit difficult to listen into, especially on shortwave. So I don't know if I should say apologies if that was difficult to listen to on 180, 160, but if you go onto the YouTube stream, if you listen to the YouTube stream, far better quality. I've definitely got a better patch to the YouTube stream. Unfortunately, the narrowband characteristics of SSB tend to really alter the characteristic there of the audio quality. Can't do too much about that. So that's why we provide a YouTube stream and an audio stream when I've got it going. But also the ATV would have been a good choice to have heard that under better conditions. So a lot of, if not most, of the audio podcasts from Brendan are generally created from folks that have logged in via Skype or some other medium, Zoom or some other kind of mode, so the audio can be a little bit restricted. But like I say, if you listen to these podcasts directly without the HF side of things, that there tend to be a bit better quality. This is VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. 10:52 is the time. And I can see John's there, VK3BLX. G'day John, who's monitoring, I think, the BATC, the YouTube stream as well. So all very good. Alright, I'll see if I can squeeze in a couple of more articles I've got here. Let me see, there is one that I want to bring up. China, again, China is such in the stream of things. China's fast observatory sees more than 1,000 radio bursts from a single spot, October 21. The largest haul of fast radio bursts observations ever recorded, all from a single fast radio burst, is helping astronomers understand what causes these fleeting cosmic phenomena. An international team of astronomers poring over data from the 500-metre aperture spherical radio telescope, or FAST, in southwest China, has documented 1,652 radio frequency flares of energy from a cosmic source about 3 billion light years away. Captured over a period of 47 days between August and October 2019, the huge collection of fast radio bursts recently reported in Nature is more than the number documented in all other studies combined. Already, the team behind the observations has used this new treasure trove to try to dissect what causes these brief and mysterious celestial explosions. Detected for the first time in 2007, FRBs are puzzling flickers of radio waves from across the cosmos that lasts thousandths of a second. They pop up multiple times a day, and each burst releases staggering amounts of energy. Some appear to be one-off explosions, while a smaller number of sources are known to repeat. The source fast zoomed in on for the study, FRB 121102, is a repeater. The first discovered and the most studied repeating source, FRB 121102, usually sends out a flurry of bursts for 90 days, followed by a silent 67-day period. Repeaters are interesting because we want to understand the behaviour. How these guys are making FRBs, says study co-author Bing Zhang, University of Nevada, Las Vegas. The more repeated bursts we get, the more we can learn. When they plotted out the energy of each of these 1652 bursts, well, that is 1,652 bursts against the burst rate, the researchers spotted a surprising feature. They could fit the energy distribution to a single best fit curve. Instead, they had to use two curves. Well, I'll just repeat that sentence again. They couldn't. I think I said they could. They couldn't. They couldn't fit the energy distribution to a single best fit curve. Instead, they had to use two curves. High energy bursts matched with distributions of previous results, whereas low energy bursts did not. It suggests that there are probably two processes at play because you have two different types of energy distributions. This is one of the researchers who was not involved in the study. Probably the source emits low energy bursts one way and high energy bursts the other, is what the suggestion is. Bursts from a magnetar. More than 50 ideas have been put forward to explain what these burst sources are, ranging from those couched in established theory like wandering pulsars or neutron star mergers to outlandish concepts like beams used to power alien light sails. Until recently, choosing which scenarios were the most probable was nigh on impossible. But this all changed last year when an FRB was found inside the Milky Way, as reported in Nature. The source of these brief bursts was known as magnetar SGR 1935 plus 2154, a highly magnetised neutron star. Just based on that observation, I think that at least some fraction of FRBs are produced by magnetars, says the researcher. In fact, many astronomers, including Zhang, now think magnetars are the leading candidate FRB source. Do the new FRB 121102 data support the magnetar picture? In a press release, co-led investigator P. Wang, National Astronomer Observatory of Chinese Academy of Sciences, stated that the study severely constrains the possibility that FRB 121102 comes from an isolated compact object like a magnetar, because too much energy was released during the observation period and there was no periodic pattern to the bursts, which would otherwise suggest the source spins or orbits at a set pace. For this part, Zhang is less pessimistic, Before his work, astronomers had put forward two main mechanisms that could explain how a magnetar could produce FRB 121102's bursts. One suggested that FRBs are generated from within the region where a magnetar's magnetic field dominates. The other posited that the shocks travelling close to light speed propagate beyond the magnetar's magnetic influence and then collide with electrons to emit characteristic bursts. The new study makes the latter possibility highly unlikely. Shock models predict a relatively low radio emission efficiency of a factor of, say, 10,000 more energy than it is wasted, says Zhang. Magnetosphere models have a much higher efficiency, he says. Based on the frequency and energy of 16,052 bursts observed, the team calculated that if shocks created FRBs could consume about 38% of the magnetar's entire energy in less than 2 months, that is crazy because this source has existed for at least 10 years, said Zhang. In contrast, Zhang says that if the observed FRBs were generated from within the star's magnetosphere, the total energy emitted is absolutely fine, he reckons. So finally, to catch the bottom of this mystery, a finely illuminated nature of FRBs, Zhang and colleagues are hopeful that the bursts start to appear close to home in the near future. FRB 121102 is a little bit too far away, he says. If we can detect say 1,000 bursts from nearby source, then we can learn more. Unfortunately, FAST, Fast Radio Telescope, only observes in an area equal to the 10th of the angular size of the full moon, making it a poor FRB hunter. For that, radio telescopes such as the Canadian Hydrogen Intensity Map Experiment, CHIME, CHIME, and that Carwell works on, are important. Observing an area roughly 1,000 times larger than the moon, CHIME spots hundreds of FRBs a year, but of these only a handful come from nearby galaxies, and so far only one has hailed from within the Milky Way. FAST has not yet spotted any FRBs from the Milky Way's magnitude due to unlucky timing. When CHIME finally does zero in on suitable nearby FRB source, FAST's enormous sensitivity can then be wielded to detect thousands of low energy bursts that would otherwise go unnoticed, and hopefully pin down how these bursts are born once and for all. Though he's guarded about the revealing details of current investigation, Zhang teases that using this approach that have already spotted something intriguing. He says, all I can say is just please stay tuned, and there should be more coming through in the near future, more excitement in that area. So that's the latest on the research going into fast radio bursts, and of course the new radio telescope embedded into a mountain range in China. The FAST is part of that, a 500 metre dish telescope which was built not too long ago, pretty brand new. So you're tuned to ASV Radio VK3EKH, coming to you from the studios of VK3CSJ in Narre Warren South. Alright, I can see it's gone 11:02. There was just a little thing here that came up here today on Facebook. This is from a news source in Derbyshire in England. I'll just briefly mention it because it's only very short, but it's interesting nevertheless. An amateur scientist transformed his little over home into a mini space research centre. This was published in May. Actually, it's a while ago now. Published in May 2019. Equipment even intercepted signals from Russian satellites. There's a picture of a house here with some funny-looking antennas on the side of the house. But what they say here is that it's amazing what you come across when searching through the Derby Telegraph archives. These great photos, taken in 1996, were used to illustrate a fascinating feature on an amateur scientist who turned his little over home into something akin to a space research centre at Jodrell Bank. Skywatcher Kenneth Stevens, then aged 80, transformed his Oaklands Avenue home into a small but hugely successful observatory, which intercepted signals from Russian satellites and created the world's first radio picture. According to the story which accompanied the photos, Kenneth's first astronomical breakthrough came in 1959 when he produced the first radio picture of the Milky Way after 60 years of research. Astronomers had said it was not possible, but during a 2-week break from his job and international combustion, Kenneth, who was a member of the Fellowship of Royal Astronomical Society, proved them wrong. He used radio waves instead of a conventional telescope and recorded an image of the galaxy made up of different sized dots using the radio energy they naturally gave off. The achievement made using a large radio telescope in his back garden was groundbreaking in the then new science of radio astronomy. At the peak of his research, mostly carried out on a shoestring budget in his spare time with the equipment made in his workshop, Kenneth was passing on new information and findings to the British Astronomical Association. As a sideline, he built an antenna which could pick up radio signals transmitted by Russians to their Sputnik spacecraft and clad one side of his house with DIY solar panels for experiments involving solar radiation. He told the Telegraph in 1996, "Most people seem to think that my observations is for research into weather and ask me what was going to be like. I usually tell them the forecast I've heard it on the radio." So anyway, that's the end of that. There's a picture of Kenneth Stevens there. I haven't got this going over YouTube. I didn't have time to capture the images. Suffice to say that there's a good picture here of Kenneth Stevens standing in front of his house with the various things leaning against the house. Yeah, so that's interesting, isn't it? The kind of things that were going on early in the piece by amateurs, in the sense. But I thought it was definitely worth reading that one out. Alright, spaceweather.com, very, very briefly. The solar wind is currently at 483.7 kilometres a second at a density of 5.7 protons per cubic centimetre, which, just as a sideline, there's a nice hurricane bearing down on the west coast of the United States, British Columbia area. I've never seen, or very rarely, ever seen a hurricane on the western side of the States, but right now they're battening down for a fairly serious hurricane coming up there on the western coast there of the States in Canada area. So very interesting to be aware of that one. Sorry, just thought of that. Solar wind. What else do you think of? On the solar sun, the disk of the sun, there is one sunspot at the moment, AR 2886. One sunspot on the disk of the sun as we speak, although there is one right on the rim, just about to come into view. Hasn't been given a designation yet. Sunspot number is currently 11, and the radio sun, measured at a wavelength of 10.7 centimetres, is currently 82 solar flux units. So as they say here, activity on the sun's eastern limb. A new sunspot group is emerging over the sun's southeastern limb. It's crackling with activity. An intensifying series of minor B-class solar flares is probably stronger than it looks because each explosion has been partially eclipsed by the edge of the sun. Okay, talking about Geostorm 20 years ago. Let's just go straight down to that. The NASA's all-sky cameras have recorded 23 fireballs over this last week, and as far as near-Earth asteroids are concerned, potentially hazardous asteroids, as of the 22nd of October, there is 2,226 potentially hazardous asteroids. but none of those are on a collision course with Earth at the moment. Potential, but nothing to worry about, of course. Alright, on that basis, that was spaceweather.com. Thanks to those guys. I think that's about it for tonight. So you've been listening to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, the ASV. More information about the Society can be found from the website at www.asv.org.au. The Dark Sky site is still currently closed. When access to the Dark Sky site will be made available fairly soon, and that information will be put on the homepage of the ASV, so stay tuned for that if you want to trip up to the ASV's website, ASV's Dark Sky site, that is to say. That's if you're a member of the ASV. If you want to become a member of the ASV, it's all there on the homepage under the membership, where it says membership. It's all open to all with interest in astronomy. Alright, this is VK3EKH with VK3CSJ on the microphone. We're concluding transmissions on our medium wave surface right now, and we'll be doing a quick callback on 80 metres, on the 80 metre surface. So this is VK3EKH concluding transmissions 1865. Thank you for listening on 160, those stations that are out there. If you want to report, you can come up on 80 metres right now if you like. Or send us an email at vk3ekh@gmail.com. This is VK3EKH with VK3CSJ on the microphones, and transmission now concluded on 1865. Standby stations on 80 metres. Alright, pen and paper, yep. Alright, so I shall take my headphones off, because that's a bit of a distraction, having those headphones on. And there it is, Matthew Mahogany and Dame Matthew Damon, what's his name? They're having a punch up on the interstellar planet. Anyway, this is VK3CSJ listening on 3541 for any stations wishing to check in.
VK3GL Bunyip. VK3HTX. The route west. VK3 Bendigo. This is Kilo 3.
Always starts off with very strong signals and then fades to a little weaker signals. There's a few there that got hit by other stations. I've got VK3GL, VK3HDX, VK3BDA, VK3VIN. Who have I missed? Go ahead.
VK3 Bravo Sierra Echo.
Alright, there's still some stations that I'm missing. The last two stations that I've got is VK7JAH and VK3BSE. There's a couple of others there that are a little bit on the weak side. Try again. Alright, there's two VK2s there. Still a bit tricky to catch those call signs. VK2 Echo, I got that. VK2 Echo something something. Try again. VK2 Echo something Sierra. I didn't quite get that second letter. VK2 something. VK2 Echo something Sierra. Try again.
Echo Kilo Sierra.
Yeah, okay. VK2 Echo Golf Sierra, is it?
Lima.
Roger. Sorry about that. VK2 Echo Lima Sierra. Gotcha. Alright, who's the other station there? The other VK2. Try that. VK3 EKH.
I think VK3 Kilo India Sierra is there too. VK3 KIN. That's the same flag as
Oh, yeah, okay. All right. VK3KIN. Was it as well? Was it VK3 Kilo India November 2?
Sierra. Kilo India Sierra.
All right, we'll come back to you when we get to you there. All right. Going to the top of the list, Graham, VK3 Golf Lima in Bunyip, VK3 EKH. Have a say, mate.
VK3 EKH, VK3GL. Yeah, very pleasant good evening to you there, Clint, and to the sundry others that have called in this evening. As you've got a fair pile-up of stations that have called in, and some of them are a wee bit difficult to hear. But anyway, a pleasant good evening to everyone. Thanks for the broadcast there this evening, Clint. Once again, quite informative and very good and entertaining to listen to. I was here for a majority of it this evening and enjoyed all the articles that you had to share with us this evening again, and watched it on the YouTube feed as well. So all came across very well. Well presented once again there, mate. Anyway, I'll catch up with you over the course of the weekend, I guess, and I might even chat to you in regards to our normal net stuff that we catch up with Bobby and all that sort of thing on 30 metres. The broadcast was really good this evening in terms of signal. You're well and truly 20 plus 40 over 9. The band is actually in pretty good shape this evening, apart from the noise and static crashes that we've got with the storm coming across. 7-3s, mate. Thanks for the broadcast, and we'll catch up with you soon. All the best. VK3 EKH, VK3 GL Bunyip.
Thanks, Graham. VK3 GL Bunyip, VK3 EKH returning, and you're about 25 over 9. Good solid signal coming in from you tonight as well. And yeah, the band's a bit noisy. I know that we had some lightning static or lightning going over us in the last hour or so, so I'm not sure how it's progressing at the moment. Anyway, thanks, Graham, and hopefully we'll catch up with Bobby over the weekend too. I'm sure he's not too far away from Adelaide, I'd say, because I think he was up at Ayers Rock there, and I think he's not too far away actually. So yep, I'll have to check the tracker. All right, enough of that. Okay, thanks, Rob. Where have you been? Rob VK3XRA has just posted a seismic event on our seismometer. Looks like about an hour ago. I don't know where that's exactly coming from or where it was. It's a reasonable one. But yeah, there's been a bit of an earthquake in the last hour. Have to check geoscience to see where that's come from, unless somebody can come up on the chat window and see where that's come from. All right, thanks, Graham. Cross to you there, Don. VK3HDX at home, I believe. VK3EKH.
Yeah, VK3EKH in the group VK3HDX. Good evening, Clint. Good evening, all. Great broadcast, Clint. Very informative. Did try to call back last week until you went clear. Actually, was yelling and yelling and yelling. But then I realised after you'd gone, the 48 volt Phantom power supply for the microphone was on. So there you go. But yeah, back in Melbourne this week, and massive signal into here on both bands, and the BA2T stream from RTV2 was excellent, as was the YouTube. Thanks again, and I'll let you get back to the cast of thousands. You've got to talk to VK3EKH, VK3HDX.
Yeah, thanks, Don. VK3HDX, VK3EKH. That would explain it. Otherwise, I would have heard you if you had been calling, that's for sure. That's such a mighty good signal too, from you 25 to 30 over 9 without a problem, indeed. Yeah, thanks, Don. Good on you. And yeah, we don't know what's happened to the RTV repeater. There has been a few little issues with it over the last week or so, but it's certainly working from a receive point of view, but not transmitting on 445.5. So that will be looked in tomorrow, I suspect, by Peter or maybe Phil. Anyway, thanks Don, good on you. Graham, VK3BDA, that's official call sign there of the Bendigo District Astronomical Society's call sign, official call sign. Take it, Graham, VK3BDA, VK3EKH.
Yeah, thanks, Clint, VK3EKH, VK3BDA, the official call sign of the Bendigo District Astronomical section of the ASC. Yeah, thanks very much for the net this evening, Clint. I've been sort of probably medically absent in recent times. I've been starting to look after Mum quite a bit more, and unfortunately she passed away on the 18th of last month. So it's been a bit of a sad time. So yeah, that's my big news, and so Gregor's sort of starting to try and get back into things. So yeah, really good on the podcast from Dr. Tasker. Yeah, really good idea putting the podcast on. Just sort of adds a little bit of extra information to it, and something that I'm sure a lot of people would appreciate being on the broadcast. So yeah, really good idea, Clint. And thanks for all the other information that you put on the net as well. Let's have that one-stop shop for sort of gaining a lot of astronomical, the latest in astronomical news, sort of one-stop shop, like I say sometimes. Because a lot of the news can be, there's that much news that occurs in the world of astronomy and space, it's sort of hard to keep track of. And but having a news every week that sort of covers the main major events, it's a good way to keep up to date. Yeah, so local Bendigo section of ASV, we had our Zoom meeting last night, and once again I was very, very impressed with some of the photographs that some of the ASV Bendigo section members, well, not only Bendigo section members, others come in too, but very impressed with all the astrophotography is just absolutely phenomenal. I mean, some of the things that you see that people are taking, it's almost like, it's been taken from the Hubble Space Telescope or something, but it's just telescopes in their backyards. I mean, it's absolutely unbelievable. And the software that's around these days, and all the technology and computerized software and that, it's just unbelievable what people can take. So we sort of had just a bit of informal, friendly chat around the group to see what people have been up to, and some people show photographs, and other people share what they've been up to with astronomy and other things. So they're happening once a month on the third Thursday, and everybody's welcome to attend. And the information is, of course, on the ASV members page under the Zoom meeting. So anyway, that's enough for me there, Clint, and just thought I'd share that news with you there, and my time is probably a little bit more freed up. I mean, I'd rather still be looking after Mum, but anyway, we don't often do that choice. So anyway, I hope all is well at your end, and hope everybody has a good weekend. Back to you there, Clint. VK3EKH, VK3BDA Bendigo.
Yeah, thanks, Graham. VK3BDA Bendigo, VK3EKH returning, and yeah, very sorry to hear about your mum there. Not too good at all, and definitely can understand. My own mother had turned 95 last Thursday, and she's not doing too bad, but there's a lot of things that are increasingly becoming more and more difficult for her, and I've now gone to part-time from working only 3 days a week, so I can be home more often to make sure that things are okay. She did have a couple of falls over this year, and her balance isn't very good. So I'm seriously thinking of retiring in the next few months, probably at the end of the year, maybe early next year, to be around 100% of the time now. So yeah, it's a. I don't. I don't want to grow old. I just don't want to grow old. At 61 years of age right now, I'm already feeling the hassles of being 61 years of age. Anyway, so yeah, yeah. Nevertheless, thanks, Graham. Good to hear you, and yeah, thanks for the report. We've been running the podcasts from Brendan O'Brien for the last few weeks now. Some of the recordings are a little bit hard on the ears on HF, but via the YouTube stream or non-shortwave, the audio is much easier to listen to, as I mentioned before. Anyway, thanks, mate. Good to hear. Take care. I saw your picture on Facebook there. I'm glad to see that you're still riding your bike and doing the various bits of exercise in that regime. So very good on you. Don't ever stop. Across to you there, Ian. VK3 Victor India November. You're next, I think, on the list. VK3 VIN, VK3 EKH.
G'day, Quint, and everybody else on the call back. VK3 EKH. VK3 VIN, and yeah, good broadcast as always. Amazing things with the fellow in England and his home-built observations. Back in and getting those signals from Russian Sputniks, etc. Quite amazing. It must have been an incredible time to be active in research of and astronomy. That's quite wonderful to hear. And in its own way, it keeps going. Just the modernisation and the technology gets hopefully better and better and better. And good news from China. We heard a mixture of news from China during the week. The other one was this space-operated nuclear weapon that they can fly around the world and drop where they want it to drop. It's a bit scary. Another use of space technology which is maybe not as good and as peaceful as the others. Anyway, your report, as in the email, 5 and 9 on 160, on a noise floor of 8, and the NZ half-wave designed for one to receive 160 anyway. When the Texan gets going, I have a loop which is supposedly to work from 500 kilohertz up to 30 megs. So should be able to give you a better report on at least on 160. 80 meters, everything between 10 and 30 over 9 is normal with a bit of phasing. Although the phasing wasn't as bad tonight. It wasn't as severe, so and your signal settles after a while from about halfway through the broadcast. It settled between 20 and 30 over 9 with pretty good audio quality. And you've explained the podcast quality on shortwave, so there ain't nothing you can do about that. But nevertheless, it was good to hear, and with a bit of concentration, all the information got through, and it's just good to get a bit of a personal profile on some of the workers. And on the earthquake, I wonder if details of where that happened have come up for you to pass on. The radio conditions in the last week have not been good, but we've been having those storms and solar flares, so that explains it. Anyway, it'll get better. Thank you again for the broadcast, and we'll listen in again next week. VK3 EKH, VK3 VIN.
Yeah, Roger, Ian, VK3VIN, VK3EKH returning. You're about 15 over 9, 15 to 20 over 9, hovering in that range, and mightily good signal down into Narre South. And thanks for the reports. And yeah, look, like I say, I really wish that the podcast recordings could sound just a little bit better. I probably could EQ it a bit better, but I need to muck around with that before I go to air, and I don't give myself enough time to do all that. So what you hear is what you get. Generally through the session, I'm fiddling with the EQ, trying to get it just a bit better, but it doesn't. If I've got the headphones on in the mixer, it's actually, I mean, there was distortion in the recording. Unfortunately, I couldn't do anything with that, but there was some peak distortion on the lady's voice, and but when you hear Brendan talk, it's so much clearer. So anyway. I've just had a quick look at geoscience, and if I'm looking at the right one, there was an earthquake in New Zealand, North Island, at 10:58 local time, 10:58, which looks about right, and it was 5.3, magnitude 5.3, and happened at 10:58. So we saw it. I'm looking at the chart on the chat window there, but we saw it just after 11 o'clock, I think. Anyway, I'll have to check all that, but that's the only earthquake that I can see in recent half hour on geoscience. So if I'm wrong on that, somebody can correct me. It's certainly not local. We've got lots of tremors that have occurred around Australia. I mean, geez, there's been a number of small earthquakes around Australia, 2 in New South Wales, and 3 or 4 are still here in Victoria, Adelaide, central New South Australia. There's been 4 in Western Australia in recent times, 1 off the coast of Western Australia, and 1 up near Broome in that corner. So lots of little interesting bits of activity occurring here in Australia. But anyway, yes, that most recent one is definitely New Zealand in this last half hour. Interesting. Anyway, all right, let's go back to the list. Thanks, Ian. Martin, VK7JAH. Have a say, VK3EKH.
Yeah, VK3EKH in the group, VK7 Juliet Upper Hotel. Good broadcast, thank you very much. Pretty clear down here. Surprisingly, in conditions, given that there is a very large rain formation coming towards you at the moment, that's kind of supporting bringing units. But nevertheless, you're sort out about 10 over 9 and very weatherable, no problem at all, I follow. So, yeah, good signal. I'm about to abandon ship down here. I've got a bit of a run between my shack and the front door. So hopefully you won't be in the middle of the storm that's coming. So I'll go back to you fairly quickly, over.
Yep, no worries, Martin, go for it. VK7JH, VK3EKH returning. Very good, Martin, thanks for the report. You're 10 to 15 over, 10 to 15 over 9, and coming through quite well. So not a problem to you, sir. Thanks for calling in. Really do appreciate that from VK7. Okay, John, VK3BSE. Good evening, VK3EKH.
VK3EKH in the group, VK3BSE. Yeah, good evening, Clint and Hams and listeners, shortwave listeners and whoever. Yeah, thanks, good broadcast. I first thought it was you were coming in about 40 over 9, but I realised I had the preamp turned on, which of course is a total waste of time really here. The signal is pretty good. Yeah, anyway, I quite enjoyed the variety of the little articles you had tonight. Yeah, it's been good. It has pretty much always is. And there's been a bit of lightning around, but it's like rumble in the sky, earthquakes in the sky. And I noticed this evening, maybe a couple of hours ago when I was outside, there was some really nice bright white lightning really sort of southeast from here. So I'm in Summers, so sort of anyway, the southeast from out through Western Port. But yeah, particularly white, and I could even also hear a while ago the static crashes behind the big two ABC radios. So they're fairly strong, healthy discharges. That's about it for now. Just experimenting with an antenna for 10 metres, sort of strung between various cables and bits and pieces, and looking at it on my little vector network analyzer in here. Anyway, all good fun things happening up there in the galaxies and wherever else, and also seeing about the rapid pulses coming from who knows where, from for whatever reason, why. Maybe it could be made by a few different reasons, who knows. Anyway, good stuff. VK3EKH and the group, VK3BSE.
Yeah, good on you, John. VK3BSE, VK3EKH returning. Yeah, that's generally a good indicator on the strength of the lightning strikes, isn't it? If you can hear the lightning crashes underneath something like the ABC radio on 774 or 621, because as we all know, they put out a magnificent signal Victoria wide, and yeah, if you can hear lightning crashes under their signal, then you know you're coming. Storm's pretty close. But having said that, we have a real-time lightning detector that's running, which can be found on the ASV website under the Radio Astronomy tab, once again, in the Radio Observatory under the Radio Telescope menu, Leon Male Radio the Leon Male Radio Observatory, LMRO. You click on that and you'll see a menu, or click on a menu to go down to our local lightning detector, which is working overtime at the moment because it's all GPS based. There's a whole bunch of lightning detectors around the world, but also in Australia, and they're all connected to the internet and GPS referenced, and each time a lightning strike is detected, it produces a strike on the map. There's a bit of a delay, just a few seconds delay, courtesy of the internet. Can't do much about that. So it's near real time, but it gives you a pretty good idea of where lightning activity is occurring. So that's another story. Anyway, but no worries. John, good signal coming in from Summers tonight. Now we go across to the VK2 station. I'm going to have to put my headphones on to focus on the sound, because the couple of VK2 stations that I've called in are a bit weak, and I don't think I've still got the call signs right. Somebody might have to help me with that. So I've taken off the sound here in the shack. So those stations, those folks listening to the YouTube stream, unfortunately you're not going to be able to hear the sound. I've got to fix that up. It's something I want to do, is to patch the audio through to the stream, so I have no problems. I used to do that many moons ago, but I haven't re-established that cable. That needs to be re-established. Anyway, so now VK2 Echo Kilo Sierra, I think it was, VK2 EKS. VK2 Echo Kilo Sierra, I think that's what I've got the right call sign there. Go ahead, VK3 EKH. Lima. Yeah, Roger, sorry, Lima. I have Lima, but I mucked it up. VK2 Echo Lima Sierra. Yep, go ahead, Alman. I think you might have mentioned your name. I didn't quite get the name. Try your name again. Did you say David? Was it David? Yeah, thanks David. Good on you, mate. Just writing it down. VK2ELS, VK3EKH. Thanks for calling in, David. A little bit difficult to copy. The band conditions are very noisy, but we do copy you. You're about readability 4. I'll give you readability 4 and about strength 9 to a little bit over. But the lightning crashes are 10, hovering around 10 over 9 sometimes, and just chopping into your signal a little bit. So, but look, thanks David for calling in, and we got your call sign right this time. Not a problem at all. And I can see you called last week too, so I should have been able to see that. No worries at all. Thanks David. Good on you, mate, and hopefully won't be so noisy next week. Thanks, mate. Good on you. Now, who was the other VK2? There was another VK2, but I don't have your call sign, I'm afraid. QZ on the VK2, the other VK2, VK3 EKH. Was there another VK2 there? VK2 something something, VK3 EKH? Alright, that's okay. Now, VK3KSN was it? I think was reported. VK3 Kilo Sierra November, is that the call sign? Oh! I tell you. Alright, that's Andrew. VK3KIS. Sorry, Andrew. A little bit of lightning static and I lose it. VK3KIS, VK3 EKH. Have a say, mate. Ooh, Andrew, VK3KIS, take the headphones off, it's hard to talk with the headphones on. VK3KIS, VK3EKH, well, sorry to say, but your signal was a bit difficult to copy. You're a good signal, you're good, you're 10 over 9, 10 to 15 over 9 signal, but your audio is being severely affected by RF feedback, I would say. Yeah, there's a little bit of RF getting into your audio, and it's really mucking up the audio, Andrew. So I could only pick up on a few comments. But otherwise, yeah, the distortion caused by the RF feedback was a little bit strong tonight. You've been better. You've definitely been better on 80 metres, but tonight looks like maybe some rain's got into something. I don't know, but anyway, yeah, a little bit of RF feedback was seriously affecting your audio transmission tonight, Andrew. But not a problem. We have you finally in the logbook here, and I don't know why I didn't hear you in the first. Maybe it was the RF feedback that was causing problems when you first called in. I don't know. Anyway, is there any other stations wishing to check in? VK3 EKH listening. Oh, hang on. Got it. All right, that's good. Thanks everybody for calling in tonight. That's been 1, 2, 3, 4, 5, 6, 7, 8, potentially 9 stations that have called in tonight. I do appreciate that. As I say, it always makes it worthwhile. Everybody on the chat window there, from Richard, VK3VRS, John, VK3BLX, Robbo, VK3GRA.
What, no VAT? I'm listening.
And
Put me down.
yeah, right, VK7JAH, and of course Tony, VK3VAT. So I knew there was another station there. Okay, all good. And thanks to the guys that have sent me emails, Don, Ian, Andrew, and
I think he's listening, Mum.
and John. So thanks very much for.
Yeah, right, you is VK3VRS and VAT. You acknowledged that I was listening.
Yeah, you're chatting behind me there. All right, so we'll do it all again next week. Thanks very much for listening and watching. Hopefully the ATV repeater will be back online next Friday for some transmissions to air. I'm sure it will be. Meanwhile, I'll be doing the WIA broadcast, the visual representation of the WIA broadcast Sunday morning at 10:30 on VK3 RTV2. That's if it's working. So look out for that, and a repeat or a rerun at 10 o'clock in Sunday night, and also the ATV net on Tuesday nights, hosted by Neil, sometimes by Ian, at 7:30. So hopefully that'll be going ahead, because that was affected last Tuesday by the output by the repeater being down. So hopefully next Tuesday it'll be all up and running. And of course then there's me again next Friday, so there you go. Anyway, thanks everybody for listening. I'm out of here. I'm going to go downstairs and watch the end of Interstellar with me mum, and we'll leave it at that. This is VK3EKH, the official station of the Astronomical Society of Victoria. All information about the ASV can be gleaned from the website at www.asv.org.au. 73 to all. Take care. Glad that we're out of lockdown here in Melbourne. Glad that's all finished and done with now. Yeah, we can only progress to summer now, and hopefully things will improve as the weather gets hotter. This is VK3EKH with VK3CSJ on the microphone, concluding transmissions on 80 metres tonight. Cheers, everyone.
Nice work. Thank you.
Thanks, Ian. Alright, TV stream. Thanks everybody watching on the TV YouTube stream. Cheers everyone, take care, look after yourselves. We'll be back here again Sunday morning at 10:30. If the repeater isn't transmitting, I'll be still doing the WIA broadcast via the YouTube stream, so you can always catch in on the YouTube stream. Meanwhile, stand by for test pattern. Cheers everyone.